In this question, we are asked to prove that if tan inverse x plus tan inverse y plus tan inverse z is equal to pi, then this condition happens: x plus y plus z is equal to xyz. The second question states that if the sum is equal to pi by 2, then this condition has to be valid. So let us try to prove one by one. So first, tan inverse x plus tan inverse y plus tan inverse y is equal to pi minus tan inverse z. I am sending tan inverse z onto that side. Remember, this is a very standard type of questions that will be asked in general subjective examinations. So first what you need to do is you have to send one of the term onto the RHS. Next, tan inverse x plus tan inverse y. So let us apply the formula for tan inverse x plus tan inverse y and apply tan on both sides. Now tan of tan inverse x plus tan inverse y is equal to tan of pi minus tan inverse of z. That is equal to, now tan inverse x plus tan inverse y, depending on what xy is, is equal to tan inverse of x plus y by 1 minus xy, or pi plus tan inverse of x plus y by 1 minus xy. So this will be either this or this. In both cases, on application of tan of tan inverse gets cancelled, and tan of pi plus theta is again tan theta, and tan inverse directly gets cancelled. Here in the second case, tan of pi plus theta is tan theta, so tan of tan inverse is again x plus y by 1 minus xy. So in both these cases, on application of tan, you get x plus y by 1 minus xy. So this is equal to tan of pi minus theta is minus tan theta. So minus tan of tan inverse z, that is equal to minus z. So if you do the cross multiplication, you get x plus y is equal to xyz minus z, and this implies x plus y plus z is equal to xyz. X plus y plus z is equal to xyz. So that is what you are asked to prove in the first question. So next question also we do this exact same thing. Tan inverse x plus tan inverse y is equal to pi by 2 minus tan inverse z. Now if you apply tan on both sides, this side will become x plus y by 1 minus xy is equal to tan of pi by 2 minus theta is cot theta. So cot of tan inverse z. So tan inverse z can be written as cot inverse of 1 by z. So now these two will get cancelled. So this implies x plus y by 1 minus xy is equal to 1 by z. This implies xz plus yz is equal to 1 minus xy, and this implies xy plus yz plus zx is equal to 1. So that's what is the second condition which is being asked.